This is Khalil Nassar with the Rokroot online debug training series. This is Concepts Virtual Address Translation. This module reviews how an address for a given byte is located via the Virtual Address Translation system in NT. The part of the microprocessor that manages memory, called the Memory Manager Unit, or MMU, operates in large chunks of memory called pages. It does this for speed and efficiency. For x86, the page is 4K in size. For finer-grained memory access, the CPU itself has instructions for manipulating data down to the bit level. As we've studied in Module 2, the computer needs to virtualize its limited physical resources so that multiple execution contexts can exist. Virtualization of this sort works by storing a copy of what's being virtualized in a safe location for each instance of virtualization. Let's say a page of physical memory maps to a certain page of virtual memory, and then the process that owns that memory goes dormant, i.e. its UI gets minimized and the process is not active. Rather than keep that physical page of memory for the dormant process, the operating system will back up or copy the contents of that memory to the page file on disk, and then reuse that physical page for virtual memory for a different process that is active. Given this, the limitation of resources, and the fact that relatively few programs typically actually need to be running at a given moment, the need for and concept of virtual memory takes shape. Given a virtual address from a 32-bit version of Windows, let's break it down into its elements. This address is not linear with regard to physical memory, but rather is encoded. In other words, virtual address 100 does not map to physical address 100, but rather virtual address 100 maps to a series of pointers that ultimately map to an arbitrary physical address. The purpose for this encoding is so that the operating system can, at its discretion, manipulate which page of physical memory is used for which page of virtual memory. For a 32-bit virtual address, the leftmost 10 bits index the page directory index off of the directory base for 1024 possible page directories. The middle 10 bits index the page table index for 1024 possible page tables, and the rightmost 12 bits index the byte within the page for 4096 possible bytes. The cool thing is that the OS, at its discretion, plugs the physical page address into the PTE, or page table entry. In conclusion, in order to enable a system that is overcommitted to run smoothly, all pieces of hardware need to be virtualized. NT uses a clever way to virtualize memory via the page directory, page table, page, byte mechanism. This allows the operating system the ability to use physical memory for the virtual memory that needs it. Thanks for studying with Module 5, Virtual Address Translation.